I'm Harrison Hong, the Executive Director of the Program for Economic Research at Columbia University. On behalf of Nagel, our new department, Chair of the Department of Economics, it's my pleasure to welcome you to the 12th Annual Kenneth J. Arrow Lectures, given this year by Colin, Camerer. These Arrow Lectures, I think, start a string of exciting events for us this spring, including the distinguished lectures which will be given by Eric Maskin, the Nobel laureate this year on April 8th, and also a special address on April 14th by our own Richard Clarida, who's currently on leave as the Vice Chairman of the U.S. Federal Reserve Board. We at the program here are working hard on a number of initiatives, new initiatives, including some workshops and conferences that we're trying out where we're partnering with some leading companies in both the finance and in the tech space to help our students and our faculty to explore the latest trends in data and technology. So let me encourage you to then explore our website for these upcoming events. And then let me close by thanking David Arrow, the son of Ken Arrow, who's here today with his new fiance, and the entire Arrow family for their support of these lectures through these many years. Welcome. And let me turn the floor over to Jan, who's going to continue the program.
Hello, everyone. My name is Jan Sveinar, so I'm part of the other group that co-sponsors these lectures. We're very proud and part of the Center on Global Economic Governance that I direct here, and it's been a pleasure to work with PER and, of course, Columbia University Press in hosting these events and then publishing the books. And I encourage all of you to have a look in the foyer where the books are displayed. It's really a remarkable set of authors who have come here to deliver the lectures and who have then published the books. Let me also recognize the Arrow Committee, which is comprised of Harrison Hong, Michael Woodford, Joseph Stiglitz, Patrick Bolton, Miles Thompson, and I'm part of it as well. It's been wonderful collaborating together on this event, and we're looking forward to doing more in the future. It's, of course, wonderful today to welcome our speaker, Colin Camerer, and the discussants. I'll serve as moderator of the event, and let me invite Mike Woodford to introduce our speaker.
Thanks, Jan. As Jan mentioned, this is the 12th annual Kenneth J. Arrow Lecture. The Kenneth J. Arrow Lecture Series is something we've been doing for more than a decade in honor of Kenneth Arrow, who, as most of you know, is probably the most distinguished PhD alumnus of the Columbia Economics Department, and also a giant of economics, not just a Nobel laureate, but one of the very first people to be awarded that prize when it was created 50 years ago. In addition to his fundamental work in economic theory, which completely transformed that part of our subject, Ken Arrow was also notable for his incredible intellectual range. And apart from his extensive contributions to economic theory, he contributed to many applied areas of economics as well, including the study of economic growth, economics of the health industry, economics of insurance markets, economics of discrimination, and so on. This lecture series features economists who've ranged from other Nobel laureates, but also to groundbreaking younger scholars, all of whose work builds on Arrow's contributions and exemplifies his spirit of bold creativity. And as Jan mentioned, the lectures are then published as a series of books by Columbia University Press, some of which you can see on the table outside the room. This year, our speaker is Colin Camerer, the Robert Kirby Professor of Behavioral Economics at Caltech, where he's also the director of the T&C Chen Center for Social and Decision Neuroscience, as well as a member of their Computational and Neural Systems Department. Colin is, I think, an extremely fitting lecturer for this series in honor of Ken Arrow. First of all, because he works on a topic of fundamental importance for the foundations of economic analysis, which is understanding the role and limits of rationality as an explanation for human behavior. But also, secondly, because Colin recognizes no apparent limits on the domain of his intellectual activity. He's taken a thoroughly interdisciplinary approach to his studies of human behavior, and as a result, he's played a leading role in several intellectual revolutions within the field of economics. Just to list some of the most important of those, Colin has been a leader in the development of what's called behavioral economics, which is the branch of the field that applies insights from psychology to the analysis of economic phenomena, and particularly in the development of behavioral game theory, which is a topic on which he's the author of the leading text. He's also played a leading role in the development of experimental economics, which is the branch of the field that uses laboratory experiments as a research method. And there he's a past president of the Economic Science Association, which is the main professional association of experimental economists. Finally, and more recently, he's also played an important role in developing the newer subfield of neuroeconomics that uses tools from neuroscience to better understand human decision-making. Colin's also a past president of the Society for Neuroeconomics and one of the co-editors of Neuroeconomics Decision-Making in the Brain, the most important textbook in that area. So he's an extremely authoritative speaker to tell us about what is known from a multidisciplinary perspective about the nature of strategic thinking. Let's all welcome Colin Camerer.
Great, thank you so much for having me. This is really an honor. A lot of people I admire are here, and I've worked with for years. I'm going to get right to it. So the first part of my talk will be very basic. So if you know nothing about game theory, I'm going to try to kind of catch you up on basic language in just 2 minutes. So by strategic thinking, I mean, for the purposes of tonight, reasoning about what others will value, believe, and choose. Thanks. And the reason I put natural limits in my title was meant to be a kind of nod to neuroscience and biology. By natural, I mean sort of nature. What is it that that evolution and also acculturation has installed? And so I'm going to talk about a family of theories. I'm going to be a little specific and mention other theories that we don't have time to get into that strive to explain the functionality of strategic thinking. Why do we think strategically? Lots of other animal species do not. Algorithms that express how that actually works mathematically, and a little bit of biological constraint. So what's a game, first of all? A game is a mathematical construction. There are players, and while I'll mostly talk about individuals being players, because that's most of the data we have to work with, we'll also talk about macroeconomic applications, where you may think of sort of sectors of the economy as being kind of roughly one player or an aggregation that you could treat as one unit. It could be genes. In theoretical biology, genes are thought to, and viruses are players, as we know. It could be a poker player. It could be diplomacy. The players have information, which is about states of nature. It might be private information, like how much I value something, and bargaining is going to kind of draw that out. Or it could be public information, like virus statistics or stock market prices or what have you. The players choose strategies. All those strategies together, sometimes they're drawn in a tree, like on the right side, will lead to an outcome. And then we assume the players have numerical values for the outcomes. Sometimes they just need to rank them, but usually we assume they'll have a numerical ranking, and they have utility or subjective value that those numbers captures. And so that's all the mathematical structure. That's a game. So far, there's really no game theory. Where the theory comes in is, can we predict something about how people will play? And then we can also back up into areas like at Caltech, we try to do science and engineering, what's often called mechanism design or market design, where if you have a model of how people will play under certain rules, you can then design the rules, like an auction or matching markets or something like that. And just so you know, if those of you who are really deeply interested in this area, if you read these papers carefully, some of them you'll have to read 2 or 3 times, and hopefully my book will be out by next year from this work. I started writing already. You will know, thanks to the magic of cultural accumulation, you'll know more than anyone else in the world, especially if you're young and you have good memory, because all of these sources are super authoritative, and they overlap quite a bit, but each of them also deals with sort of different aspects of this rapidly emerging field, and a little bit different than what my book will actually be much shorter and a little bit more compact. Okay, So tonight we're going to talk about two types of models. One is called equilibrium, and those are the things that are taught in every single class and have been the kind of workhorse analysis to understand mathematically if the behavioral strategies people choose satisfy certain mathematical properties, we can tell what might happen. And so there are two properties that prove to be the most useful. Choices are optimal given beliefs, or you can kind of soften that sometimes and say they're stochastically optimal, like in a Duncan loose, with a little bit of error or trembling, and beliefs are accurate. That's really what gives the theory a lot of precision and force. So somehow people have come to figure out what others are likely to do, whether by learning or by asking them or something of that. And I'm going to contrast equilibrium analysis with a cognitive hierarchy. And as you can see in the lower left, there's a few other theories that also depart from equilibrium analysis and the goal is to be very principled, to be behaviorally more realistic, but mathematically workable and useful, and also to explain a lot of different things with one common set of tools. We don't really want a different theory for each game or each thing in the human economy. And the cognitive hierarchy model has two, sort of a starter step, and then the rest is kind of mechanical. There are zero-step thinkers who are assumed to not think strategically. They pick lucky numbers. They may not realize they're kind of playing a game, or they're sort of bewildered. But they're important because other players know that they exist. At least that's the presumption. That's the part of the theory. And so a one-step player thinks they're playing zero-step players. A two-step thinks they're playing ones, or maybe ones and zeros. And a three-step thinks they're playing twos and so forth. In that specification, everybody thinks they're smarter than everybody else. So now, you can easily change the math so the two-step players think there are some other two-step players. So there's sort of some shared self-awareness. That changes the math a little bit, and mostly we're going to talk about models that do not have that property. So everyone thinks they're smarter than everyone else. But it's easy to, there's a whole family of these models where you can toggle the dials to get different interesting things to happen, and this has been a very active area of research. So I promised lab, brain, field in the title. I'm going to talk about a couple of lab experiments. One's actually not. You may not even notice. Brain, a little bit, field data, and then kind of what lies ahead. And my discussants, I think, are going to fill in a lot of interesting gaps of things I don't have too much time to talk about. So we're going to start with what's called a beauty contest game. The term beauty contest comes from Keynes. And the idea is people choose a number from 0 to 100. How many people have heard of this game? Quite a few of you will have. Okay, perfect. Some of you won't. People choose a number from 0 to 100. We're going to compute the average. 2/3 of the average wins. So everyone wants to be 2/3 of the average, knowing that everyone wants to be 2/3 of the average. And there are a lot of experiments in this. Let me just show you the data first. On the left is data we collected from National University of Singapore. So these are engineering students. They're very smart. This is not a random sample of humanity. They're unusually analytical. And the Nash equilibrium prediction is that everyone will pick a number which is the best response to the number that everyone picks. So the winning number will be x, which is 2/3 of x. And the solution to that equation, when I said it that way, is 0. So if you think others will pick 50, you pick 33. But remember, your beliefs have to be accurate. So if everyone thinks that, everyone now has to think people pick 33. But wait a minute, then you'll pick 22. But if your beliefs have to be accurate, you must figure out that everyone's going to pick 22. And that process of iterated reasoning doesn't stop until you get all the way to 0. Okay? Here. And what the people actually do, which is the data in maroon, University of Chicago colors, is to pick numbers that are dispersed. A few pick 0. The average of their numbers is typically around 30. So the 2/3 of the average is around 20. And so 0 is the Nash equilibrium. It is not a winning number. So notice that in this case, the Nash equilibrium is not good advice about how to play. You'd like to have advice like, how many steps of reasoning do people do? So it's useful to know the Nash equilibrium. For example, if you play the game over and over with feedback each time, you will move towards 0. So 0 is a number that is scientifically important, but it will not win you the game. It's kind of too clever by half. On the right, you see a graph that Grossman-Milgrom made, which is several thousand people playing different by mail, where they mailed in, nowadays there's done by email, mailed in numbers to Expansion, FT, and Spectrum, which are business magazines and journals. And the beauty of this is there's so much data that you can see a spike at 33 and a clear spike at 22, and then a lot of people picking 0 and 1. Okay, so these steps of reasoning, 33, 22, kind of pop out of the data, but there's also a lot of things, numbers that are around those. Here's the data from the New York Times. This is 55,000 people, and you can see the winner here, 2/3 of the average was 19. The average of all guesses is 28. What happened in the New York Times is you log on, you put your number in, and then boom, it shows you this graph. And you can see the number I put in was 20, so it's just off of 19. And again, you can see these beautiful spikes, a big spike at 50. So those are people who are too high. They're just not thinking much about the game, and the 50 is the average. There's people picking 66, right? That's 2/3 of 100. So, they're probably just missing the key component of the game. They just didn't think through it correctly. There's a lot of them. And again, these are New York Times people who logged on to the New York Times website. So this is not a random sample. These are people who are unusually wealthy, probably uneducated, and weird, as Joe Henrich says, Western, and so forth. But you can see the spike at 33 and another 22, and very much like in Rosemary's media data, there's a lot of ones and zeros, and here's me. Okay. So the cognitive hierarchy theory, just to reiterate, the 0 steps choose something salient. We think in games like the 2/3 of the average, it's either like a random distribution of different numbers, or it could be like pockets of lucky numbers or 50s or something like that. The 1-step thinkers think they're 0, 2-step think they're 0 or 1, and so on. The next thing we have to do to kind of close the model is what is the distribution of how many levels people are likely to do. So we use a particular functional form just for kind of economy, and because it has a cool French name, and it has E, which is a Poisson distribution. Poisson distribution has this formula, and it's characterized by one number, which is the mean and the variance. So if you tell me that number, I know everything I need to know. And it also has, it's plausible, we think, in a kind of crude psychological way, because the Poisson distribution, like if it's 1.5 is the number tau, which is the mean and the variance. If it's 1.5, the peak is at 1, level 1. That's like people picking 33, right? And then it goes down very rapidly because of the structure of the exponential, of the factorial. And so very few people do 4, 5, 6 steps. So when you look at data sets, we don't think there's level 7 and level 8 are usually very frequent or sort of very important. Okay, here's another game. It looks a little similar to Beauty Contest, but it's in some ways much more interesting. This is, we call the Loopy game. And so Robert Ostling is a Swedish economist. He came to Caltech for a while, and we didn't do any particular stuff there, but then he left and emailed and said, I have these data from a lottery. Do you want to analyze them? And 53,000 people played this lottery. The way you play is you go to a store and you pick up one of these cards, and there's 6 spots on the card, and you can pick out numbers, and there's 5 rows. So if you pick digits from 0 to 9, you can basically pick a number from 1 to 99,999, then you run out of rows. And so everybody picks an integer number, like 1, 114, 22, 56, and so forth. And then the lowest unique number that day, it's played every day for 49 days, wins 10,000 euros. Okay? And so you want to be low, but unique. So it's a really cool game because the low part is easy, but the unique part is not, right? And also we have 49 days worth of this data. We don't have individual level data, we just have like the group. So we don't know if you played one day, if you did the similar things, or you changed. But we also, just to advertise, we then did a field in the lab. We then created a lab experiment that was kind of like Sweden, except it wasn't 53,000 people and it wasn't cards and everything. And we found kind of pretty similar results. So in this case, we go not from lab to field, all the way around. So first thing is, what's the solution to this game in equilibrium game theory terms? What's a benchmark? So it turns out there's a lot of incredibly interesting arcane math. If the number of players is known, like we know you're playing 53,000 people, you cannot compute the Nash equilibrium. By you, I mean me and you and everyone else in the world. Maybe Kenneth J, I would not have bet against, right? As there's so many stories about the scope of his wisdom. But it turns out you can't compute it in the same way that you can't compute the solution to chess. It's just beyond computing capacity because of a combinatorial explosion. But if the number of people who are playing is not the same every day, it varies, because it's just, people decide if they want to bet or not. If that distribution happens to have a Poisson distribution, it's just a coincidence. Thanks to Roger Myerson, the Nobel laureate, he showed that if he was interested in things like voting, where different numbers of people may vote. So you're not sure how many people you're voting against. And so he invented a class of Poisson-Nash games in which the number of players had a distribution. And that's actually very useful in thinking about auctions and voting and things. Large groups of people are deciding how many people are taking the subway or, self-quarantining for a corona or something like that. So it turns out if that's the case, then there is a closed form solution which you can derive, you meaning Robert Ostling and Joseph Wong, and it consists of all these equations. So P of k is the percentage of time any individual will play the number k. So P of 1, is how frequent is the choice of the number 1. P of 2 is how many people pick 2. P of 3 is P of, and so forth. So you compute all the P's and then they add up to 1 and you get a nice, beautiful, elegant solution. And here's what it looks like. It has a wild structure. So the most common thing that should be picked is 1. 2 should be slightly less common, 3 and 4. So you should see this kind of, shelf of people choosing the lowest numbers going down very slightly to 5,500 to 13, and then it just plunges. Like, who knew? The designers of the auction didn't. Nobody had solved for this when they designed the auction. So we don't think anyone in Sweden had this curve in mind. And this gives us a very bold prediction, which is, right, remember that you can pick up to 100,000 on the card. But the theory says the top 95,000 numbers nobody will pick. So this game theory with 0 free parameters, there's no free parameters, right? It's just the Poisson-Nash equilibrium restriction. And this is the unique mixed strategy equilibrium. With those restrictions, we can make an exact prediction. It's completely counterintuitive. And it tells you that the top 95% of numbers on that card will never be played. So let's see what happens. So this graph here shows this in kind of high relief. If you plot the same exact thing, it shrinks and looks like this. It's the same distribution, but just scaled down. And this is all the 100,000 numbers. As you can see, very few people do pick the really high numbers, but there's a few. There's a few. This is a vertical, this is not data, this is a vertical line at 10,000, because I'm going to cut the lowest 10,000 and show you that slice in a minute, like expanded. And a lot of people pick low numbers. So there's too many low numbers. There's a gap here between about 2 and 5,000. That's where most of the winners are, because not enough people picked in that zone. And so if you picked in there, you're probably going to be unique and low enough. And all the 1s and 2s are not unique because a bunch of people picked those. So when you blow that up, it looks like this. Here's the Poisson-Nash prediction. These are all the same data, just the graphs are moving around the scales and everything. And you can see there's too many low numbers. So what's going on is the low part of the task is easy. The unique part is hard. You have to think strategically for unique, right? So the lower level players are not going to get the unique right. So the most common thing people pick is 1. So these are Swedes who think, 1, that's low. No one will play 1, right? And 150 people played 1, or 2, or 3. Well, I'm not a dope who's going to play 1. I'm picking 2. And 146 people picked 2. Okay, so as I mentioned, there's a gap where not enough people are picking in here. So the game theory is pretty good, right? It predicts that above 5,000 are hardly anyone picks. That prediction is correct. It's just that it doesn't quite fit the curve beautifully, right? And so there's room for cognitive hierarchy to say, why is it that people pick these low numbers, and there's a gap here, and then you do also get some kind of stochastic picking much higher numbers. Those are people who are trying really hard to be unique, but they turn out to just be not the lowest unique person. If you pick, for example, 99,614, you will be unique, but not low enough. Okay, so they're getting part of the half the equation. So it turns out if you fit the cognitive hierarchy model with a stochastic function, because it has to smooth choices out over a lot of numbers, it just doesn't fit otherwise. You get a really nice fit with a value of 1.80, which is very close to what we often see from game theory data, like the 2/3 of the average game. Like 1.5 or 2 seems to be kind of where, like a characterization of what people are typically, average groups of people are typically doing. And it explains, you can see the nice curve. It's a single parameter plus the stochastic choice parameter, 2 parameters, and it fits the curve pretty nicely. Now, what happens over time? This is a GIF. Thank you, Robert. You can see this is just going to loop every day. We have new data. So day 1, it starts with a lot of people. You can see the people picking 1 are gradually learning not to pick 1. You're going to see a bunch of 2000s popping up. You might guess what those are. Those are birth years, probably, like people who are born in 1980. Interestingly, they don't pick, 1980 isn't chosen as frequently as 1981 and 1979. So there's a little bit of strategic thinking. If you're born in 1980, you think, I'm not going to pick 1980, I'm going to pick 1979, right? So they're actually avoiding the roundest numbers, but in the whole profile, a lot of people are picking those numbers in that range. And as you go across the 49 days, what's going to happen is, see this big gap area? It gets filled in as people pick higher and higher numbers. There's a TV show every night that shows you the winning number, so if you watch the TV show. So by the end of the 49 days, the data is pretty close to the Poisson-Nash equilibrium. So this is both a story about how starting out with Nash equilibrium as your prediction is not a great starting point, but over 49 days, it's really a pretty beautiful prediction with no free parameters. So this is not a talk about how stupid game theory is. It's about how game theoretic, very counterintuitive game theoretic intuitions from classic game theory, updated by Poisson and Roger Myerson, this was not in von Neumann Morgenstern, predicts pretty well. Okay, I'm going to pause for the big picture. And so by big picture, I mean, I gave you a particular theory that has a lot of sort of restrictions on it from an econometrician's point of view. You know, there's a certain number of steps and blah, blah, blah. And in neuroeconomics, a little, not particularly in behavioral economics, but in neuroeconomics, we think that good theory should be able to do 3 things. And this is very different than how people typically think in economics. It's very standard in cognitive neuroscience. And so I'm hoping for in some ways, there's some applications in economics in which this way of thinking will actually be helpful and may catch on. And so this is a picture due to Krakauer. But the basic idea here was due to David Marr, who was a visual neuroscientist who unfortunately died in his 30s, but he left this beautiful book with Tomas Poggio, or worked with Tomas, and he left this idea. So I call this a Marr chart. And so what Marr said was, what is the visual system trying to do? If we don't understand what it's trying to do in the world, we won't really understand the mechanisms. So we really should have a sort of loosely coupled, I mean, if it can be tightly coupled, that's better, but it may be loosely coupled understanding of the why problem, what is the visual system trying to do, the algorithm, like what is an equation, if you were going to build an artificial eye, what would be the blueprint, and then implementation, which is what is the raw material, like neurons, neurochemical dopamine, testosterone, skin, right? You know, how did nature build this thing in flesh and blood? And so this example has to do with bird flight, right? What's the purpose of bird flight? Is to get up in the air, to either hunt if you're a peregrine falcon, or to escape, or to migrate. So we need to be able to get up in the air. What is the algorithm? Well, you could write down like a blueprint, you know, for how you'd build a bird wing, and then how are the bird wings actually built in nature? Like light bones, and there's feathers, and so forth. So when we think about natural strategic thinking, the way I think about it is, what's the function of strategic thinking? What do we need it for? Well, a lot of animals don't really have mentalizing in the way that we think of humans. They don't need it. Why do people need it? We need it because we cooperate with one another, even though if we're not genetically linked. And we need to write things down and understand if the intent of the author was to communicate positively. So if you read Vince Crawford's paper or my book, am I trying to actually educate you or trick you? Right? We need to separate friend and foe. We might need to strategic think from a morality purposes. I might want to know, did you intend to harm that person? In which case you should go to jail, or was it an accident? So that has to do with thinking about the contents of your mind, like mens rea, the mind of a criminal. I should say the research connecting these 3 pieces doesn't really exist, because the strategic thinking part mostly lives in developmental psychology. You know, how do children acquire steps of thinking? in comparing species, like other species other than humans who do a lot of mentalizing. There's a huge debate in primatology whether other organisms mentalize and have a theory of mind like we do. And I think linking these would be a cool thing to do, but it's well beyond, obviously, what we typically think about in economics or even in neuroscience. The algorithms are the things I mentioned. The way typically in game theory, what people value is something we just assume. We sort of assume a game matrix, and then we see how people play when the values are known, where they have to think about beliefs and so forth. And then implementation is a picture I'm going to come to in a minute. So in order to think about the Marr chart, me and Rosemary and a small number of people from economics backgrounds and a lot of people in neuroscience, including Mike Shadlin, Daphne Shohami here, and Jackie Gottlieb a little bit, are interested in the actual implementation in the brain of elements of strategic thinking, whether it's attention, mentalizing, et cetera. So if I had more time, I would show you a lot of pictures of eye tracking, but I'm just going to show you one. And so this is a picture from Eric and I. Eric Johnson's here. And in the late 1980s, we had a wonderful student, Rachel Crowson, who now is a dean. She's a big distinguished career and now has graduated to deaning. And she had the idea of using MouseLab. So MouseLab was a system that put information in boxes that were hidden. So you knew you didn't know the number that was in there or the word, but you knew that it was something like the price of apartment A. And if you moved a mouse and opened the box, you could see the price of apartment A. This was a thing that was actually used with little wooden charts for years, and then Eric and his colleagues developed an electronic way to do it. And the beauty of MouseLab is you can have hundreds of people doing this at the same time. And so you can see, like, what are you looking at on a screen, because you have to open this box to look at it. Okay, and now we also use things like eye tracking, which is used to study reading, where we just have a camera that can tell where your eye is looking. But those are expensive, and MouseLab is cheap. So it's like a Costco for behavioral game theorists. And what Eric and I did is, I know this is a very busy graph. I'm sorry about that. But I'm just going to show you this one graph with mouse data. We were interested in alternating offer bargaining. So that's a paradigm that people were very interested in the 90s, where you started with $5, and player one would offer an amount of that to the other player. Like, well, how about if you take 2, and I'll keep 3. And the other player could say no, and then the amount that they could divide would shrink to $2.50. And they could say, well, 2 is too little. Out of the $2.50, I want $1.75, and you get 75 cents. Notice that they turned down $2.50 and offered $1.75. So people must not be maximizing money. There must be we think there's some concern for fairness or for relative income, not just dollars. And that's why people were so fascinated by this game, because you would see people turning down money. And so Eric and I noticed that these icon graphs show you the percentage of time in blue that people were looking at this number. So these numbers varied. It wasn't always $5, $2.50, $25. It was 3 different numbers that just went from high to low. And this is how often they were looking. Most people just looked at the middle number and the top. And about a quarter of the time, they didn't even look at the third box. Like, who cares about that? It turns out in game theory, you should look at the third box, and then back to the second box, and then back to the first box to compute what's called the subgame perfect equilibrium. They just didn't do it. They just didn't do it. And so it was hard to get this paper published, because people would say things like, game theory has nothing to do with what people look at. Okay. The prediction is that people who are blind and not blind will behave the same way. I think we could probably disprove that one. Sort of. People were just not ready, people meaning game theorists who were trying to understand the predictions, just were not ready to integrate the math with what people looked at. But anyway, a paper got published, and a lot of other people now have gone much further to use eye tracking as a way of trying to understand these algorithms. But that's not exactly the brain yet. I mean, the eyes are attached to the brain, and they're telling us about sort of some hidden cognition, more than if you just ask people questions, for example. So I'm just going to show one brain study, although there's quite a few, and my book will say a little bit more. So Rosemary and Giorgio Corselli did a beautiful paper 10 years ago. They had people play a bunch of the 2/3 of the average type games, remember, 2/3 times the average, except it wasn't always 2/3. So they varied the multiple, they call it M. Sometimes it was a half. And so the people who picked 33 in the 2/3 of the average game would pick half of 50, 25. So you could see if they picked the multiple times 50, that they were like level 1 players. And if they picked the multiple times the multiple, they were level 2 players. They were responding to people responding to random players by others. So you could behaviorally classify 1s and 2s in this way. And then what they also had people play others, they're having their brain scanned using whole brain fMRI, and they have people playing other people or a computer that's random. Because that controls for like all these things on the screen and the fact that your finger moves to press a button, and so there's activity in motor cortex. So we're going to subtract activity when you're playing a person minus playing a computer, and what we're going to see is the specialized activity associated to mentalizing about another person. Okay, and so you see a circuit, we call this a circuit, meaning it's a bunch of areas that are activated at the same time. And typically we either have other data or an idea of whether they're functionally connected. You know, like is the temporal parietal junction functionally connected, or is it sort of passing information to dorsolateral prefrontal cortex? I can say yes. Not this graph doesn't prove it, but other evidence from neuroscience, you know, gives us support for this kind of idea. And so most of these areas are part of what's called the mentalizing circuit, dorsomedial and TPJ. And then if you compare the highest level people, so remember these are people now judged by their behavior. Like these are the people who pick 22 compared to the people who pick 33. And the 22 pickers have a lot more activity when they play people versus computers in dorsomedial pre-FC. So you can kind of see the differences in strategic thinking in the brain. Okay, now onto the field. I already showed you one field application already, actually, Loopy. Remember that? It looked like an experiment because the game is so simple, but that was a Swedish lottery. We didn't like invent it and recruit people, right? So I showed you that one, but that wasn't one of like typical economic interest. It was sort of an artificial lottery invented by the Swedes. It wasn't, you know, there's no antitrust and so on. So there's a bunch of other papers, beginning with Avi Goldfarb and Mo Xiao on telephones. A beautiful paper just came out by Ali Hartachu and others. There's a couple of papers looking at timber auctions. And in each of these cases, they have sort of different levels of behavior by managers or bidders or firms bidding for electricity. And they try to use this same structural model and see, can this help us understand things that are going on? And I'm going to show you one example that we did. This is movies. And so this is a movie called Adventures of Pluto Nash. From 2000 to 2006, 7% of movies were not shown to film critics in time for them to publish a review in the newspaper on Friday. And now things have changed dramatically, right? So in 2000 and 2009, which is the data we analyze, back in the day, the reviews that were posted online and people came on like the nightly talk shows with Johnny Carson and David Letterman, and they promote their movies. You know, all that pre-movie publicity was sort of a big deal. And so not allowing critics to see this usually meant nobody went on the talk shows because they wouldn't show a clip, right? And that number later went up. So Eddie Murphy's movie, for example, is Cold Open, which means it came out on Friday and no critics reviewed it. So there's a theory about when critics should review or not, and it's a beautiful theory. I'll come to it in a second. This is a Neil Jordan movie by Colin Farrell. My middle initial's Farrell also. His middle name is Farrell, so I'm Colin Farrell Camerer. Often confused by this gentleman, by drunk people in Ireland. This has got a Metacritic score of 65. Metacritic is an aggregator website that takes a whole bunch of different critics and just averages them, and it scores them from 0 to 100. So 65 is pretty good, although it's not at the very top. Here's a 21. Catherine Haig, Ashton Kutcher, and Killers. And if you notice, this is like the Sherlock Holmes, the dog that didn't bark, right? There's something you see in this ad which you do not see here, which is quotes from the critics. And they got those quotes because they sent the movie to critics to see a few days early. They sent their review as a courtesy to the publicists that was going to come out on Friday. And when they made these posters that got in the LA Times advertising section, they took out parts of the review. So if you don't see any blurbs like this, that means nobody got to see it. That's bad news. That's bad news. So there's a beautiful theory due to Joe's collaborator Sandy Grossman and also Paul Milgrom, two really brilliant people, about when you would expect voluntary disclosure. That we kind of force it to try to apply here. The idea is, suppose there's one number that determines quality, right? Now, for movies, it's really not. Metacritic is like 0 to 100. That's quality. And again, that's a simplification, but it enables us to kind of do some math and apply theory. So this is a bell-shaped distribution. This is not too far from the actual distribution I'm going to show you in a minute for all the 900 movies in our sample. So we're going to assume the studio knows the quality, up to some noise or some dispersion. And so if the quality is 50 or above, you should probably show it to critics, because if you don't show any movies to critics, they'll think they're all around 50, if people have rational expectations based on what they know from the critics. So the movie studios will show the 50s and above to critics. That means if you see in the newspaper no quotes when you see killers, you think, oh, it's probably kind of below average. The conditional expectation of the left part of this curve is 36. It's like, that's probably around a 36. Now, the people who made movies that are between 36 and 50, they wanted the critics to say, well, this isn't below average, but it's above 36, right? So you show that to the critics. It's like, this is no Katherine Hagel, Ashton Kutcher movie, right? God forbid. So you're going to show these to critics. Then, if over a period of time, moviegoers get used to seeing these data, or somehow some form of these data, then the movies that don't get shown to critics will have a conditional expectation of 25, and then the 25s to the 36 will get shown. So the argument by Milgrom and Grossman was that you'll have voluntary disclosure, because non-disclosure means no news is bad news. Consumers will figure that out, and you'll get disclosure from all except for the very bottom, where it doesn't really matter. Okay. But this theory relies on consumers knowing that non-disclosure is bad news. No news is bad news, right? So it relies on rationality of the consumers. And so this is the actual data. These are the fractions of movies in different categories, from rated the very best to rated the weakest, that were cold open. The colds are in red. And as you can see, all the movies above average were shown with, I think there's two movies, or 3 here. Of the lowest quality movies, the Ashton Kutcher, Katherine Hagel's right here at 21, half of those were not shown to critics. So if you knew of these data, you would think, if I don't see a review, it's probably well below average. Okay. And so the movie theaters are kind of gambling that not everybody makes that inference. So in order to study this further, I'm going to speed up a little bit. We run a regression, which is the box office, how much the movie actually earns, how many people will go and pay. That's going to be a function of the expected quality, plus a bunch of variables like star power and number of movie screens and advertising budgets, and documentaries are a category that earns less than comedies and things like that. And then, but what is the expected quality? We're going to assume that the reviewed movie is the expected quality is the actual quality from Metacritic. We also have data from moviegoers from IMDb, and those are actually surprisingly highly correlated. And for the cold open movies, we assume that the expected quality is above the actual quality because of the limited naive strategic thinking. And we actually wrote 2 papers. One is the data I'm going to show you, and the other we try to structurally estimate how many levels of thinking is going on, and that one was much more complicated. So when we run a regression, and we estimate it this way, we're going to put a number 1 for cold opened, and then put the quality in. And the coefficient alpha C in this regression should be positive, should be above 0, if there's limited strategic thinking by the moviegoers. So they're kind of fooled by an unshown movie. The expected quality is above the actual. And we're going to see how big that is. How much extra box office do you get by not showing to critics, so that people who don't think that means much go by mistake. They're like, oh man, I wish I'd known. Or it could be 0, which is the rational imputations type prediction. And so I'm going to show you the residuals from that regression. We leave out 2 things, which is the cold opening dummy, which is red versus blue, and we leave out the quality rating. So you can see that there is a positive relation between box office and quality. And there's a gap between the red line and the blue line. That gap is the premium, is the extra amount you earn from cold opening. And here's our pals right there. It's about 15%. Okay, finally, a couple of quick things, and then I'm going to rush to the finish. So macroeconomics. just discovered in the last year or two, and especially in the last 3 days, crash coursing for this talk, that macroeconomists have begun to think about level K type models in a very sophisticated way, but at a much higher level. This is not the scanning the brain, this is not moviegoers, this is not people in Sweden, but it's the same models that are used to see if we can understand some complicated questions in so-called new Keynesian macro. One of them is called the forward guidance puzzle. The idea is if the Fed says 2 years from now we're going to change something, if people believe that, and the credibility question is maybe a very interesting one, but let's assume that people believe it, do they actually act on it? Does that change the macroeconomy right away? It might not if people aren't sure that other people are sure about what other people are sure about. So the same kind of higher order uncertainty about whether others will behave in a strategic way, you can use to like move these models around to see what happens. It turns out we're not the first people, I should say, the folks like Mike working on this, and a lot of other people actually in modern macro theory were not the first people. Think about it, Evans and Ramey did. They proposed it as a model of iterate expectations, but it just never got too much traction. They did this almost exactly at the same time as the level K models were emerging from Nagel and Vince Crawford and me and Stahl and Wilson. Actually, I'm going to, let me just show you how this works. So this is a typical aggregate consumption function, which means consumption at time t is a function of interest rates, YT, which is aggregate output, how much money is floating around the economy, and expectations about future output. And so the way they build in level K is that level 1 players think that they're conscious of what the output will be this period, but they maintain the same expectations about the future. So when the announcement is made, they don't think, oh, that's going to change future output. Like, well, it's probably I don't know what this is going to do, so I'm going to assume nothing. The level 2 players plug in what these level 1 players think, which is here, and they plug it in there. And the level K players plug in. And so what happens is, the point of these, if you don't know some macro, this is going to be very bewildering, correct? It's okay to nod. Yes. The point of these graphs is, what this shows you is the elasticity response of output to interest rate. So how much does current output respond to this future promise or forward guidance, right? And if people are highly rational and rational expectations, they should respond right away. But as you can see, the response rates are mitigated if the K level is low. Mitigation means the response is lower than predicted. And it goes down the further in the future the promise is. That's called the horizon effect. So the forward guidance does not empirically seem to have the effects that are predicted in the classic models. But this is a paper by Farhay and Verning, and in Michael's paper with Garcia Schmidt, this is just a slightly different way of doing it, actually an importantly different way of doing it mathematically that's really quite close, surprisingly close to the game theory models. And what they find is this is what they call the forward stable perfect forecast equilibrium. This is if people were were iterating over what people think. They get to this kind of like very sophisticated equilibrium. This is the response of output, that's Y, inflation, that's pi. This is based on the fact that the Fed says we're going to use a decreasing Taylor rule intercept. Basically, we're going to slowly lower interest rates for 8 quarters, and after that, we're going to use what's called the Taylor rule to kind of reset monetary policy. And what this basically shows you is if you plug in steps of reasoning from point 4, point 8, point 2, you get slower responses of output and inflation to this announcement by the Fed. The idea is that there's sluggishness because people aren't sure, that people are sure, that people are sure. And numerically, it looks within spitting distance of the kinds of things we see from game theory. Final thing is, this is very important, but I have to go quite fast. Can the level K model account for failures and successes of equilibrium prediction? So far I've kind of shown you things where the Nash equilibrium prediction is like 0 and that number is wrong. The Loopy prediction is that you should pick numbers like 4,000. Not enough people pick 4,000. I've shown you like where the theories are wrong and we can do better. But it turns out it's more complicated than that. This is John Nash. It's not John Nash, it's Russell Crowe. And there's a famous scene in A Beautiful Mind in which it does not age well. Let me just put it that way about this scene. One blonde woman and 4 brunettes show up in a bar, and Nash is there with like a pile of papers and his cute tousled hair, like absent-minded professoring, and his bro friends come over and is like, oh man, are you gonna go for the blonde or the brunette? And he says, well, you know, they all want the blonde. If we all go for the blonde, we'll cancel each other out, so we should go for the brunette. Adam Smith was wrong. Now, unfortunately, this is the only real game theory in the paper, and it's really a mess. Because the game they're describing is called a game of chicken. It has the following payoffs. And the idea is, if there's one desirable thing, like driving and not swerving, one person should do it, the other person should back down. If nobody backs down, that's bad for everybody. That's everyone like sexually harassing the blonde. And if nobody approaches the blonde, there's a Pareto inefficiency, somebody missed out on their opportunity. So the idea that Nash equilibrium is that you shouldn't approach the blonde is just completely a mess. Every game theorist who's watched this movie is like, the movie's ruined. The movie's ruined for me. I'm gonna have to skip this out of time, but you can read it in the book. Anyway, here's a real life example that's similar to what the movie was trying to portray. These are called entry games. The idea is there's n entrants. There's a capacity C, like the size of an industry. You can either stay in, enter, or stay out. If you stay out, you get a payoff of 1, okay? If you enter, you get a payoff of 2, as long as C or fewer people enter. If too many enter, you get 0. So you're kind of gambling on whether few people will enter like you, or if too many people enter, you want to stay out. And the Nash equilibria all have the property that about C people enter. Like if there's 100 of us in the room and the C number is 24, and we go around, we should get 24 people saying enter, approximately. How? Like how? Like in the experiments we did, nobody gets to talk. You don't go in order. We didn't explain game theory. Right? You're just told, write down yes or no, and we're going to add up the yeses, and here's the money. So it turns out, here's the data. This is the data from experiments we did at Caltech. So the data is noisy, of course, but it goes up. And Danny Kahneman did some experiments like this with Jim Brander and Dick Thaler, and he wrote about these in a book in 1988. And interestingly, Danny was he says, observing the regularity of behavior in this market was a bewildering experience. He made this in a nice way. You can take it differently, but to a psychologist, it looked almost like magic. So they actually didn't write up the results because they didn't know what to make of the fact that the number of people entering was pretty close to the value of C, even though there was no communication or history. Like they didn't have a dynamic process that would tell them why that was. To Danny, it was like magic, right? But it turns out if you go through the logic of level K, what happens is the level zeros will enter no matter what. Like they just ignore the capacity. So the level 1s will say, if the capacity is low, it's too crowded with all those crazy people, I'm staying out. If the level's high, not enough crazy people went in, I'm going in. And so that's going to generate a conditional curve that looks like that. The level 2s will kind of fill in the gaps. If you add the level 0s and 1s and 2s, you get this step function. As you add in more and more types, the higher level types are kind of filling in the mistakes, where not enough people entered or too many people entered. And so you can show that if tau equals 1.25, for example, you can prove mathematically that this curve has to be increasing monotonically. And there's a little bit of over-entry at low levels and not quite enough entry at high levels. That's like a vestige of the zeros fooling around. But this is why the magic happened. Okay. And more generally, in a case like the beauty contest game, what happened is if people are picking a number that's too high, you have to be too high too. You're not going to pull them towards 0, right? So irrational players deviating from 0, it's the strategies are what called strategic complements. You're going to be too high also. So the rational people are not going to like correct the excesses or the deviations. And on the other hand, in games like Loopy, if everyone's picking 1, that creates room for you to like smooth out the distribution by kind of you want to fill in the holes where not enough people picked, because that's the unique spot, right? And so if you have strategic complements, level K models will get you close to Nash equilibrium. That's why you'll get a equilibration. Not because Nash was right about half the world and wrong about half the world, because the rational people will fill in the gaps. If there's strategic complements, which could happen with, say, price bubbles and asset markets and short horizons, right? If everyone's paying and you can't afford to short sell Tesla because you have a short horizon and you don't want your fund to blow up, then you're going to get things like persistent asset price bubbles. And I think this distinction may have important implications for organizational structure and in macro and other things. So let me end there. There's a bunch of interesting things to do in this research. David Sally, shameless plug for my former student, wrote a book about this. So if you think, can level K thinking help me win negotiations? He has a PhD. He's very smart. It's actually a really good book. It's got interesting science in it and then tons of stories. And the things we need to understand most are, other than what the discussants will bring up, which are probably even bigger picture, what exactly is this level zeros? Because they're like the tail that wags the dog. So we need to understand them much better. And we don't want to have a different level zero for every kind of game. We'd like to have a real principle like, tell me the game you want to study and I'll tell you what I think level zeros will do, and then we can compute everything from there. There's some beautiful work endogenizing levels. Like we'd like to say, why do some people stop at 2 and stop at 3? We kind of gave up on that, but Alawi and Penta from Pompeo Fabra have a beautiful paper. We'd like to see a lot more field applications. It's great that people after I talked to Mike today in the afternoon, he gave me one new paper on level K, and I went back and looked it up, and I found 2 others. So there's a bunch of papers, floating out there, and in 5 years there might be 10 or 15 or 20 more papers, all, working out slightly different models and different data sets, and there's going to be a lot of exciting work on that. And then I think, of course, there's lots of interesting biology, including things like computational psychiatry. When are brains, paranoia and gullibility and autism spectrum disorder, these are all things that have to do with social calculations that are misfiring in some way. And so there's a bunch of people in computational psychiatry who actually use games as a kind of way of diagnosing things like that. Thank you very much.
Thank you. Thank you very much, Colin. This was wonderful, great food for thought. We have 3 excellent discussants. I'll be very brief because time is of essence in introducing them. Joe Stiglitz is Joe Stiglitz. Nobody needs to introduce. University professor here, Nobel Prize winner. He is co-chair of the high-level expert group at OECD. Was president, vice president, senior vice president, chief economist at the World Bank. I'll stop right there. Author of many books, so I'll stop there. Rosemary Nagel, professor and director of Best Lab at University Pompeu Fabra, research professor at ICREA at Barcelona School of Economics. Has done a lot of work, as you could already see, in the area. Has worked a lot with Al Roth. We had the privilege of overlapping actually for a year at the University of Pittsburgh, so it's great to be rejoined with her here. Carla Hoff is a visiting professor here at the SIPA School and was the lead economist at the World Bank before joining here, co-directing the World Bank Development Report in 2015, dealing with mind, society, and behavior, and again has done a lot of work in the area. So I will not go into additional details. You can look them up. And let's start with Joe Stiglitz as the first discussant.
I want to spend just a few minutes talking about Ken Arrow, who is this talk is in memory of. And as pointed out, we started the series 12 years ago because to honor Ken. Ken honored us by coming every year to discuss the lecture, to give his reactions. One of the reasons for having a series in honor of Ken was that the span of his work was so enormous that we could every year have a different talk on a different aspect of his work, and so have an enormous variety of topics. And in many ways, Colin's talk has brought together lots of topics into one talk. And the books that were out there illustrate some of the range of the topics. And the, just to put again more pressure, the lecturers have actually been very good about actually writing up their books and delivering them. Another reason we wanted to honor Ken is we wanted our students to realize what a typical PhD from Columbia was like. that his book, Social Choice and Individual Values, which really revolutionized. It was, it just really came out of nowhere. It was anybody who knows the book realized how really creative, original it was. That was his PhD thesis. So we thought it would be good for everybody here to sort of have the norm set so that they would at least aspire that high. So for those who are graduate students here, that's what we expect of you. When Ken died, there was a very moving and a great tribute to him in the New York Times by a great economic journalist, Michael Weinstein. And let me just quote some of the things he said. He says he was one of the most brilliant economic minds of the 20th century. And Paul Samuelson described him as the most important theorist of the 20th century in economics. And I think both of those statements are true and reflect the greatness of, not only did he, most people would have rested on the laurels of that thesis, or what he did a little bit later where he proved the existence of the competitive equilibrium and the fundamental theorem of welfare economics, which established the conditions under which Adam Smith's invisible hand was true. I mean, that was really, itself was a foundational contribution. But this is really important. After he did prove the fundamental theorem of welfare economics, unlike a lot of people, say at Chicago, and I'm just picking that as a random university, who took that theorem as if it were true and took the view that markets were efficient, he realized the limits, that what he had proven was that the markets were only efficient under very restrictive conditions. And then he spent years trying to elaborate on what happened if you got rid of some of those conditions, like perfect information. He went on to the theory of moral hazard, the theory of adverse selection. He understood, and I'll come back to this in a second, he understood that markets were not perfect, that he talked about the importance of power. He talked about discrimination, economic discrimination. And he talked about externalities, learning by doing, endogenous information, R&D. So all the things that everybody forgot about, he understood the assumptions that went into his model, and I think it really is an example of a model economist. The other wonderful thing about Ken was he was not just an academic. He was an activist, and he was not just studying what was going on in our society and our economy. He was participating in it in very many different ways. At one of the memorial services for Ken, one of his students talked about the day after he came to Stanford. He was driving in San Francisco, and he went by, and I think it was at Woolworth's, there was a picket line about their segregation in the South, and he couldn't believe it, and he saw Ken was marching there with everybody else, and he stopped, and Ken looked at him and said, "Is everything okay?" And he said, "Yes." What do you, and very quickly Ken realized that there was no problem. First he was worried about there was something, the student had a problem, and he was worried about the student. But as soon as he was clear that there was no problem, he went back to the picket line. So I had the good fortune of being a student of Ken in 1964, a few years ago. And then I went to, he invited me out to Stanford at what it's called IMSSS, and we became, and then I went to Stanford, and we became very good friends. We had a play reading group together. But we also had the chance to collaborate on a number of areas in which we were engaged. One of them was in the Economists for Peace and Security, which was particularly important at particular points where we were at war. And another one was on climate change. I was one of the lead authors in the second assessment 1995 report of the IPCC. And so you try to get people to bring people together to start thinking about the issues like discounting. And so I asked Ken to join with me, and we wrote a joint paper together on the appropriate methodology for discounting in the presence of uncertainty. I only wish Bill Nordhaus had read that paper, either then or now, and he would understand that climate change is a much more, the response to climate change is really different in the presence of uncertainty than in the absence of uncertainty. So that brings me really to, unfortunately, the subject of the talk, which is really about how people with limited cognition behave in a whole variety of situations. And we know that they don't act rationally. And, you know, we were saying that the first problem when they were presenting what is the right solution to that two-thirds, you know, those of us who are indoctrinated in game theory, you know, we look at that, it's obvious, it's zero. But it's quite obvious that it's not obvious for everybody that that's, and so what the point of this is, there are people who are not fully rational. And that is really a very important insight. And once you recognize that, and you have to then recognize that it's rational to recognize that there are irrational people. To not recognize that there are irrational people is irrational. And so that opens up in a fundamental way, a different way of looking at economic behavior. And that's what the strand of work that Colin has been engaged in for a very long time is concerned with. And so it's really a fundamental departure from the tenets which have been at the core of economics for a very long time. As he said at the very end, understanding the nature of those irrationalities, their persistence, the circumstances, you know, how people behave, is very difficult and is not really fully understood. And that's what makes the subject both difficult and I think going to be a rich subject going forward. But in the few minutes I have, I just want to raise just a couple questions. One of them is in economic situations, we're often in the repeated game where we're doing things over and over again. The situations where Colin suggested things begin to look more like, often, not always, and that was important, often look like, more like the game theory would predict. And the second thing is that we're often in situations which are not strategic. When we're interacting, you know, or at least not as strategic as this. When we're interacting in markets, as we as individuals, as small players, don't think that what we do is going to change what our telephone company is going to do, or, you know, collectively we may, but individually there's very little strategic interaction. So when I was first doing some of my work in imperfect information, like with Mike Rothschild, and equilibrium insurance markets with adverse selection, we began thinking very much along the lines of I have to, the insurance company, I know the insurance company is going to make inference about my behavior from my choice. The insurance company knows that I'm going to be making that inference, and then you can see that infinite unraveling. Actually, in one of my 75 papers, I went through the unraveling that Grossman talked about when the theory of screening. So you can go through that. But we decided to skip that and go to, is there an equilibrium that we can describe? And that, of course, is the self-selection equilibrium. So in the market equilibrium, people aren't doing that. There's a set of contracts that are put out there. With that set of contracts, the self-selection constraints are satisfied. And it, you know, in that particular context, it can be sustained. So the issue, in a way that I'm raising, it has to do with, in many market contexts, we've learned we're not strategic players, and when we are, we often repeat occurrence. So we've done the learning. So that maybe is the last point I'm going to make, which is in a lot of real life situations, there is at the center of what goes on is learning. We're trying to learn. And we're trying to learn about the market. And one of the things that Colin is emphasizing is, in some ways, we're learning about how other people behave, and they're learning from us. And one of the questions is, what determines the characteristics of that learning process? And the speed of the learning, whether we converge, does it converge to an equilibrium that looks anything like a Nash equilibrium? And that's, of course, a subject that's been widely studied. But maybe the one point that I'll mention, and I think probably Carla will elaborate on this to some extent, we can think of ourselves as having both hardware and software. There are certain aspects of what we do may be our universal characteristics. They're really a reflection of the way the brain is wired. But a lot of it is the software that's put on our brain and ourselves by our culture, on what we've learned. And that means that people growing up in different societies with different experiences are going to behave differently. So one of the problems is that when we confront people with a challenge in an unusual situation, you know, life is not full of beauty contests. It's part of life, or the Swedish lottery or the other games. People are going to have to make a jump from the kinds of experiences they've had to these particular kinds of games, and from real life to experimental games. And in doing that, the analogies will be imperfect. They're going to be making some jumps. It's sort of like one of the motivations for Tversky's early work that he told me, you know, back in the 70s was that as in the Israeli army working in the desert, they had to be retrained to see distance in the desert because their eyes have been adjusted to making distance in light that had a certain characteristics. But you have the hot heat of the desert, distance looked different. And so the brain had to be recalculated to learn. So one of the problems is that we each learn in our particular environment, and when you put that into a different environment, they'll make some analogies, but they may not be real good descriptions how we behave in real life. So this is not new for Colin. He wrote actually a very interesting article that I called "Differences in Behavior and Brain Activity During Hypothetical and Real Choices." So this is not but this is actually an important thing in trying to understand the relationship between these very, really important insights and trying to understand how real economies behave.
So my talk basically will be about 3 important questions in experimental economics discussed with cognitive hierarchy or level K. So let me first bring you what the questions are. Colin raised. What is game theory good for if observed human behavior contradicts it? That's a very old question which already John Nash got from when he wrote his thesis. Yeah, and he wasn't very convinced that it's good for human behavior. Then another question Colin and his co-authors brought up when they started to study neuroeconomics. Why economics needs a brain? And I think there are still quite a few economists who think we don't need the brain. And another question is, what can the lab tell us about the field? And I will deal more with the first and second question. And basically what Colin showed is how cognitive hierarchy or level K can help. Let me therefore first review quickly cognitive hierarchy and level K. So these were 2 graphs Colin showed. The beauty contest game, choose a number between 0 and 100, and the winner wins 2/3 of the average, which was done in the field study, and the Loopy game. So the level K model actually came out of my thesis. I was a graduate student in LSE, and I was just a student in a class, and I picked 22. And I was and then we repeated the game, and I was the winner of this game. So I thought maybe I understand what is going on in this game, and there I developed with the data, of course, the level K model. So what is level K? The level 0 is between 0 and 100, 50. A naive player might choose a random number of 50. In other games, it can be past observations, as we know from Cournot, or it can be a focal point. But many other things, and Colin actually has a big research on the salience and what level K actually, level 0 can be. And level 1, level 2, that's just an iteration. And I focus on these best reply best reply responses, because that is very important when we think about the question, what is game theory good for? Yeah, and eventually the Nash equilibrium is played. So we have discrete types of players. We have iterated best reply model. No specification here of the distribution, but maybe the average behavior, that's very important in macro. I mean, you look at an aggregation, can be predicted because typically the behavior is between level 0 and 3. So basically we have here endogenous shocks in the brain of the subjects. And later, Colin has already mentioned that in macro, this model has now been applied as a behavioral feature. And maybe then, if you use this kind of feature, you don't need exogenous shocks. Yeah, you can use these endogenous shocks in order to explain out of equilibrium behavior. So that is a very nice feature of this model. It's all endogenous. And from the empirical data of the lab experiments, maybe you can conclude also what happens in the field. Now, the cognitive hierarchy is basically a parameterization of the level K model, and then it becomes a very good predictive model, which the level K model is not really. It's more a cognitive reasoning model, which is actually what goes on in the brain of the people. And we have thousands of comments from the newspaper experiment, actually, where these kinds of reasoning, level 1, level 2 is seen. But it is also seen, what Colin then introduces, that the level K best replies to known level 0s to K minus 1. Yeah, so there are actually players who send in Excel files and they say there are that many level 0, that many level 1, etc. So Colin introduces a 1-parameter model, and he assumes a Poisson distribution. I mean, the problem is only that basically you need a known level K, 0 to K minus 1 distribution. he mentions a little bit that this model, the cognitive hierarchy model actually doesn't explain so much the beauty contest data, and the level K model doesn't really say much about the Loopy game. So we have weaknesses, but Colin's talk is really about contrasts between models and complementarity. So we can really say the different models, they complement very nicely each other, as the lab experiment very nicely complements the field. There were fights in the early days that once we have field experiments, we don't need lab experiments. But Colin showed very nicely how this works together. And also here, the level K model has its beauty, namely that it's really what is going on in the head of the single people, as I showed as a graduate student. But it has this problem of making prediction is more difficult. And when Colin basically estimates this one parameter, he can go to a new game and just plugs in the known parameter of another game and can check whether this makes a good prediction. So the empirical finding is that levels are typically between 0 and 3. Colin also mentioned other studies who wanted to get to this level K model. There were the problems that these models had maybe only 1, 2, 3 strategies. So you couldn't really say where people stop. Do they really stop at 2? Because there are 3. But what happens if you have 17 iterations to equilibrium? Yeah, where would a person then stop? And with this game, the beauty contest game, you could really nicely see where people stop. And what Colin also mentioned is that these kinds of models are very flexible. They can mimic equilibrium behavior when really equilibrium is played, as in the entry game, or they can very nicely show out of equilibrium behavior, that there is a clear structure. The important is that you get a structure. And this structure actually comes also from game theory, because rationalizability, where you start from 100 and then iterate down, starting with dominated strategy, gives us a nice structure. Yeah, but in game theory, you don't have maybe this naive player who does something not like deleting dominated strategies. So because of this level 0, this model becomes relatively flexible, and that has been sharply criticized by theorists, that you have such a flexible level 0 point. However, in real life, we have our reference points for each situation. It might be very different. And therefore, as Colin said, studying the level 0 is highly important. Now let's come to my questions. And I do these questions with one slide only, and I pop in certain words. So we have game theory, which is logical, as we know. We have behavior, and we have nature, which here is the brain. And I pop in some other natural things which we have in our body. So these are separate entities. The psychologists maybe studied behavior. Maybe they didn't have the mathematical game theory. And the neuroscientists, they didn't have game theory. They didn't have the same mathematical foundation for actually interacting players. And I emphasize especially the interaction of players that economists are very good in. So in the middle, in the center, we put in cognitive hierarchy, level K. And this is important because in life, we have uncertainty. If we had no uncertainty about the environment or what other players do, like maybe in the animal world, you have more impulses which are very clear to the other animals, we would not need a difference maybe between game theory and behavior and the brain. Yeah, so maybe in nature you have cells that do everything rationally because they don't have to react to uncertainties of others. Then, the first question now is, how does game theory and behavior interact with not having this conflict that the equilibrium is not always seen? Can we dismiss? I mean, that was a long-standing question. Should we dismiss game theory since it doesn't comply with the behavior? No. We have in game theory the model and the solution. And I put the structure in the middle. The model is what Colin said, players, actions, information, and outcomes. And we get structure through game theory. And from all social sciences, I think economists are the best to model this interaction. Now, the behavior might be different. However, we can bring both together. And how do we bring it together? Well, we use experiments. We put players into these models, and then we check what they do in surveys, what is now modern, it was not allowed, and we can distinguish between experts and students. And then we see deliberation. We see best response. That's a feature of equilibrium. Well, it's only not always consistent, which we saw in the beauty contest game. Actually, as a side remark, my friend and co-author John Nash, he played this game, and I would like you to guess what he played. He played, and his wife also played this game, so he played 67. And that is really his belief. 0 he would never have picked. He would have known it. Yeah, but he didn't believe so deeply into what humans do. But he was also not so good in outguessing other people. So he was better in modeling and modeling. And one of the people here in the room, very clever, very famous, picked 0. Yeah, so that's also not the right answer. Nash's wife actually picked 4. And I can assure you that they would agree that I tell that here. So we have now, only since 2000, we have also, Colin mentioned that in macroeconomics now, cognitive hierarchy and level K is also implemented, and Mike Woodford actually was the first one, and I helped him a little bit to think about this implication. So how about nature? Well, nature is actually something very different. It's an organism where every part is important, even if we don't know whether it's important. So you can't really say, let's take one part out, which we think we can take some humans out. We need heavy machinery, fMRI, and in order to get into the brain. And here we get not only the experts, but we are very interested to get people who have lesions. Yeah, and Colin mentioned that the brain really shows that level 2 players behave very differently than level 1 players. And that's very nice. So the theory of mind has been introduced by neuroscientists without the economists. So that is the putting it together. So how about emotions? How about hormones? How about sleep? We now know quite well about viruses. The viruses that is currently around will shape our behavior. We don't shake hands anymore, and maybe we do other things. So sleep deprivation might reduce cognitive reasoning, and there are studies which shows that people who are sleep deprived use different strategies. So morning people and late night people, maybe they are not so good in the time when they are really wanting to sleep. And we have to really consider in economic models and also in policies more that these kinds of hormones or our sleep attitudes shape our behavior, and therefore we should take this out also into account. With this, basically, I want to conclude what Colin did not talk about, and what I now, having been here in Columbia, worked more on is he left out the humanities. But in my picture, actually, if you know humanities, if you know important philosophers who survived even their death, I mean, that they are still amongst us, this picture actually was very much influenced by my study on Kant and Hegel. And those of you who have studied Kant and Hegel might see it. Hegel said there's logic, there is spirit, and there is nature. And this is behind these words. And I hope to work on merging humanities together with what you see here in the words, and that actually we should not kill humanities in our universities, even though maybe the clear-cut profit maximization is not seen, which economists currently think is the most important ingredient in the studies. Okay, that's basically with what I conclude.
So we heard two very exciting discussions of what have been called natural limits on strategic thinking. We are social animals. We are completed by culture. If you put a baby in a box and just feed it and keep it warm, that baby will not grow up to be a thinking creature. We think with cultural and social constructs. So in the very few minutes that remain, I will talk about what Joe Stiglitz called the software that also gives us very important limits, natural limits, because we are social animals. I'm thinking in lab, brain, and field. I just want to start out with a really trivial kind of sociocultural constraint, and that is that our thinking is shaped by our native language. If you have a different native language than I do, you will see certain things differently, even if we both have 20/20 vision. And that's because we always see selectively, we associate selectively, and your language gives you associations. In German, a bridge is feminine, die Brücke. In Spanish, a bridge is masculine. In a little experiment, participants who all spoke English but had different native languages were asked to describe photos. So, for example, they were asked to describe a bridge, which happens to be feminine in German and masculine in Spanish. The typical description by the German speakers was, the bridge is beautiful, elegant, words that would be much more natural to use for a woman than for a man. But the Spanish speakers described the very same photo as big and dangerous. So they just see things differently. There is a missing variable in economic models that people like Bob Schiller and George Akerlof are trying very hard to fill. And those are the categories and the narratives and other cultural schemas or mental models that mediate our experience of a situation. When we looked at that bridge, we didn't see it just as some bridge. We saw it as die Brücke. That gave us associations. New experiences will therefore change our associations. They will change how we play games. So I've been working on this since 2010 with Joe Stiglitz. Greif and Mokir have very much been working on this in their careers. Gautam Rao got his job at Harvard based on one experiment he did showing how rich kids in elite private Delhi schools changed how they played games strategically, changed how they thought of others, changed how they discriminated against poor kids when, because of a Supreme Court decision in Delhi, they all of a sudden found that 20% of their classmates were very poor and they interacted with them. And that just changed their associations. It changed how they saw games. This is a very, very big deal for practical applications. Now, we had wonderful examples that I learned a lot from both Colin and Rosemary. I'm never going to go to a movie that doesn't have quotes from some reviewer again, never. I want to give you one practical implication, a recent paper that I really loved by Sendhil Mullainathan and a million other people whose names I couldn't list in this short slide, which was evaluating a set of programs, most of which are called Becoming a Man, that was done only on males. So all the subjects are males, thousands of them, and either they're in Chicago schools or they are in prisons. And we're going to show you how collective representations that these people have very reasonably learned from their environments constrain them when they move to a new environment. So again, this is Heller Melanothan's work, not my work, but I just love this example. Joe and I have done many other examples of cultural thinking that produces bad outcomes, but this is the best example I know. So you're a disadvantaged kid, you live in the ghetto, and you learn very quickly to act tough, because if you don't act tough, people will prey on you, take your girl, take your car, take your radio, take your watch, maybe take your life. And if you're an adaptive guy, then when you get to school, you will be compliant and cooperative. Now, a middle-class kid doesn't have any problem because she can act the same way on the street and in school. She can always be cooperative and compliant because there aren't so many predators. Now, in real life, we're not so clever as to understand there are a million different environments we need to adapt to. So the typical disadvantaged young man will act tough in school and on the job, just as he's learned quite correctly to act tough in the ghetto. But that gets into trouble. If a teacher tells you, and now I'm really just quoting to the best of my memory, the Heller et al. Paper, if a teacher tells you, sit down, be quiet, I want to start class, you definitely should comply. It's in your self-interest to comply. You want to learn something. You want to get the teacher to start talking. But if you're a ghetto kid, you might feel that your status or honor was at stake, and you might not be immediately compliant. This gets you suspended. You get suspended enough, you don't graduate. You don't graduate from high school, you have no options in the formal labor market. They did a bunch of RCTs, very big, very large scale, just to teach disadvantaged youth to think differently about games. Not to be tough and aggressive in the ghetto, but to recognize there are other environments where that kind of response is not helpful. So just a cute example, divide kids into pairs. In each pair, one is given a ball. The other is told he's got 30 seconds to get the ball from him. Almost all the boys use physical force. I grab Colin and I just take the ball out of him, and maybe I hit him in the process. And almost all the boys do that. And then the leader asks the other boy, like he asked Colin, would you have given it to him if he'd asked nicely? And of course Colin says, yes, it's just a ball. So they learn there are environments where you can cooperate. The participation in this RCT reduces arrests of 7th to 10th grade boys from violent crime by almost half, and it reduces recidivism among the prisoners by 21%. So there are natural constraints on thinking. You're never going to get me to be an infinite level thinker, except maybe in a game you teach me, like not to see a movie that wasn't reviewed, or how to play the beauty contest game. But you can expose me to a new culture and give me practice in thinking. And now there are a lot of interventions that really show how exposing people to new kinds of situations changes. My favorite paper is a recent econometric paper by John Sheo that show just exposing Israeli voters to the stock market gets them to vote 5% more for pro-peace parties. So in the remaining 5 minutes, and I really am done, I can just, so I'll just make a comment and then I'm done. Ken Arrow, although he never left the framework of the rational choice theory, he never recognized or focused on the way we're K-level thinkers and how we should not limit ourselves to analyzing Nash, but instead K-level thinkers where we have Poisson distributions of levels of thinkers. Still, Arrow pushed at the boundaries of all fields, including behavioral economics. So he comments in 2010, "Today psychology is invading economics, the whole field of behavioral economics. I believe that sociology should play more of a role in economics than it does. But it's not so easy to construct a broad theory." I put that in because I've heard 10,000 times behavioral economics defined as psych plus econ. But at the very same time, I've heard behavioral economics defined as economics based on a more realistic notion of the human actor. Those two statements are wildly inconsistent. The human actor is a creature of society. The German speaker saw the bridge differently than the Spanish speaker. The ghetto kid plays the game of sharing a ball differently than the non-ghetto kid. We are completed by culture. We are born, unlike the alligator who apparently can start hunting prey pretty much the day he's born. We are not born like that. We are shaped by our culture. And if we want to learn how to use game theory to get better, more realistic predictions, and how we can use policy to get people to play interactions better, I think we should bring in sociocultural influences. And there's a lot of work in top papers that is beginning to do that.
Anybody would like to comment or ask question? You don't have to, but this is an opportunity perhaps that somebody would like to take advantage of. Going. There's one. Okay. Very good.
My question is that, sorry. Thank you. Thank you for this presentation tonight. It was briefly mentioned about different aspects of climate change, and I was wondering, does game theory have any involvement with like climate change and like space exploration, and can make different predictions on how we invest and how our behavior is towards climate change and climate science and space exploration?
Okay, if there is one more question, let's take it together and then we'll have the answers. Okay, there is one.
I've heard that like Colin and the other like discussants have all like mentioned at least some about like cross-cultural issues. Like, I heard that Colin mentioned weird, the Western educated, that stuff. I'm curious that, so recently there is growing literature showing that like Western and Eastern people, even at the neuroscience level, even at the brain level, they function extremely differently. And I wonder if a lot of these kind of behavioral econ thoughts and neuroecon thoughts, they're just from the weird samples. So how do you think of the future like perspectives of applying these stories more into the less developing world, and especially the East? Thank you.
Okay, maybe we'll ask then, starting with Colin and the other two to react. Thank you.
Hello. Yeah, the climate one is very complicated. I'll just say one tiny thing, which there's an idea that came from social psychology called pluralistic ignorance, and it's the idea is I'll give a better example than I think some of the originating examples. There's a recent paper, I cannot recall the authors at all, but they asked men in a Muslim country whether they would like their wives to work, and I'm going to just give you a guesstimate number that's going to be faithful to the point of the study, but is wrong numerically. And let's say 60% of the men said yes. And they asked them what they thought other men would say. And they said they thought other men would say 30%. And then I think the paper went a bit further because they were interested in kind of causal manipulations and behavior change. And they kind of gave feedback to everybody. And the men all realized, actually, everyone kind of wants their wives to work. But I thought I would be judged by my neighbors as somehow breaking a moral norm of allowing my wife to work, even though everyone wants their wives to work. And then there was an actual uptick in female labor participation. So I think it's a little startling to us in economics. So we think of how would that information not flow in the economy or in everyday discussions in some way? But, there may well be things of that sort where if you were to poll people, a lot of people really feel a certain way, but they think other people don't. And then it's the higher order misperceptions of what the low order perception is that become substantial obstacles. And one thing you might expect to see in the face of these kind of higher order gaps is that when things change, they change fast. Because all of a sudden everybody realizes nobody minds if their wife works, and they're not going to judge me if my wife works. And you get really rapid inflections in social behavior. So I think there's at least a hope that for some aspects of climate change, things like that may work to our, and it doesn't really have to do with level K. It has more to the idea that there could be a widespread belief which is different than people's belief about what the widespread belief is, and then that becomes a bit of a fulcrum for change. As far as weird, I think most of the cognitive constraints that we have in mind for level K are going to show up in lots of small-scale societies. The biggest differences have to do with probably with sociality. So I worked with Joe Henrich, many talented anthropologists, and Gene Ensminger on some project where we went and ran the same kinds of game theory experiments in lots of different small-scale societies. And these are really small-scale, like you have to fly to Quito, Ecuador, and then take a rattletrap bus through the mountains and take your life into your hands, and then take a boat. And there were differences there in sort of sharing norms. Like there's societies where in a $10 ultimatum game, I offer you $1 and you take it. Because, of course, we don't share money with each other. And other societies where I offer you $3, it's like, where's my $5 out of 10? So there were substantial differences of that kind that seemed to reflect acculturation about sharing norms, and which were associated with how much market trade and sometimes religiosity and a few things like that. And I don't know what the mechanism is. I wish there were more weird. Weird is an acronym, by the way, for Western, educated, industrialized, rich, democratic. And the idea is that many areas of social science are, even economics in some ways, are very heavily focused on developed economies. And when we think about financial markets, we think about the NYSE or the London Stock Exchange. And it's particularly appalling because I was involved in a Twitter argument about this, where there was an interesting paper about whether people fasting for Ramadan, whether it affects cognition. Probably it does, but maybe it's not if people are acclimated or there's workarounds or what have you. I mean, it seemed like it, and a psychology journal editor had rejected this on the grounds that this was a specific religious thing that was of little relevance about general human behavior, even though being hungry is a general human behavior, and 24% of the population is Muslims. And so I would hope that data like that would be actually really interesting opportunities to look at. I mean, the point of general behavior is you study lots of different groups, and what's general is the intersection, and what's different is the what's excluded from the intersections. There seems to be a problem in a lot of social sciences in just getting people out to these domains, establishing that there's something extremely interesting about that domain, and then getting through this publication process where something that required studying every unusual society becomes a feature that's really special and valued, as opposed to kind of a bug and like, why don't you just do it on MTurk? So a lot of people are kind of fed up with this and would like to see more weird data being somehow collected.
Non-weird.
Well, the
Non-weird,
judges which
you mean.
don't have breakfast, the study.
Yeah.
The
Weird.
judges.
Oh, I'm sorry. Yeah, non-weird. Yeah, sorry. Yeah, in other words, non-weird, i.e., more typical senses of lots of all the different interesting varieties of behavior in the world, as well as institutional developments, norms. The phrase weird was coined by Joe Henrich and Nozarayan and a third author in a behavioral brain sciences paper, which every behavioral scientist should read. It's beautiful. It's not that long. And the scope. It
starts out with an outrageous sexual story to sell it, and it wasn't.
I wasn't going to mention that.
They did that.
It's so outrageous that even having been warned by Colin it's outrageous, you still will find it outrageous. anyway, it's a big challenge.
It's still a great paper.
Yeah. It's a big challenge, and it's gotten easier and easier. I mean, it's still difficult to travel to very small scale societies like Joe Henrich did in the Machagenga in Peru, but there are lots of other ways in which accessing you can bring iPads, and also you can measure lots of things about these folks. That's what cultural anthropologists do when they go. They measure diet and all kinds of stuff, and we should take money and fund more cultural anthropology of that kind, and make sure the papers can get published in where people see them and learn from them, learn from these really remarkable types of situations.
Thank you. Rosemary, anything? Don't have to.
I pass it. No, I want to say, I mean, what he says, we really have to bring hormones and our body more into the picture. So there are studies about judges behave differently if they have breakfast or not. Yeah, I mean, this cannot be. I mean, we know that judges behave differently when there are different people they are not so acquainted to.
They don't give anyone parole if they haven't had a recent meal.
Yeah.
That's what she's saying.
Yeah.
Hangry, instead of hanging judges, is hangry judges.
So the brain is basically one thing, and Colin only talked about the brain, but there are a lot of hormone stories. So if you give people oxytocin, they will act differently in trust games. Yeah. Well, something like that. Yeah. I mean, some dispute that.
Yeah.
But
All right.
Okay, well, to participate in this fabulous group, I can't resist saying something. So I appreciated very much the comment about how, East Asians are very different from North Americans in a whole series of tests. I guess Dick Nisbet wrote a whole book on that. I wanted to make a comment really on the field of behavioral economics very broadly. I feel that it does not recognize the existence of weird people.
well, Lesion people says. But
No, weird as in Western. It doesn't recognize the category, the specialness, the ontological limitations of generalizing about human beings when you're studying weird people, Western educated, industrial, and so on. And I feel there's a lot of tension in Kahneman and Tversky because, while on the one hand, Tversky got into behavioral economics partly because of his very youthful experience recognizing that people in the Israeli army in the desert misjudged distance because they were just assuming that what works in Israel works, or what works in a more humid environment works in a dry environment. I'd say there's really a tendency in all of behavioral economics, starting with Kahneman and Tversky, to think that when you do an experiment with people from any one place, that you've learned something about human beings. And one of the ways I think that the field is getting enriched, which is really just what Colin was talking about, is that you're bringing in careful studies of very, very different societies from those most subjects are drawn from. And we're learning that the things that Kahneman and Tversky said were universal aren't universal. So I'll just give one example, which I thought was really cute. Somebody goes off to some remote place in Tanzania and compares people in this really remote place to people in the slightly less remote place where there is a lot of tourism. And where there's a lot of tourism, there are institutions and there are property rights. But where it's really remote, there aren't property rights. And then he plays a game to check for the endowment effect, which is supposed to be universal, like anchoring. And the endowment effect didn't apply to those people that didn't already have the institution of private property. So we think with sociocultural constructions, and all our behavior is an outcome of both our hardware and our software. And we shouldn't make claims about hardware when the software we know varies across cultures.
Well, let me thank you on behalf of the Program for Economic Research and the Center on Global Economic Governance. And please join me in thanking Colin, Rosemary, and Carla.